Today we're going to continue working on our law of exponents. In the last block you learned about the product rule and you also learned about the quotient rule. So today we have 3 more rules that we're going to add on, and I think the key with all of these rules is once you have the basic understanding of them, you just have to really make sure that you memorize them and know when to use each rule and in what situation. Alright, so we're going to start with the power of a power property. That's the first example here. So with this, the real key that you're looking for is parentheses. Here we have n to the a power, and all of that is taken to the b power, the b sitting outside of our parentheses. The power of a power property is basically multiply these two exponents. And the reason why this works is if we look at this example here, we have x to the second power, all of that is taken to the third power. If we apply our rule by simply multiplying those numbers, we get x to the sixth. If we really think about what this means, it means that x squared to the third power means that we're just multiplying x squared times x squared times x squared. We're multiplying it by itself 3 times, which if we write this all out means that we have x times x, which is that x squared, x times x, and x times x, which gives us x to the 6th power. We're just taking all these x's times each other 6 times, and that's what x to the 6th means. So this is how we can see that this rule works. Now, I would rather use the rule and multiply these numbers than write all these x's out. So that's why we're going to use the rule. So let's do a couple of practice examples. Here we have b to the 5th power, so we're going to multiply, and we're going to take that to the 2nd power, so we're going to multiply that 5 and that 2, so this becomes b to the 10th power. The next example, we have y squared, and we're taking that to the 3rd power, so we multiply the 2 times the 3, and we get y to the 6th power. And then on this last one, we have m to the 10th power, and then we're taking all of that to the 2nd power, which means we take take the 10 times 2, which gives us m to the 20th power. All right, so we're just going to look at this rule a little bit more in depth here, because when we have the power of a product property, we don't always just have one thing in the parentheses. So here's an example. We have x times n to the a power. All of that is taken to the b power. So in this example, we have the b, which is going to be taken to this x term, and that b is also going to be applied to the n to the a term. So in reality, we have here, think of it as a rainbow, and send the power into the parentheses. Let it hit every base. So here we take this b, and we're going to take this x. This is really x to the 1st power, if we think about it. And so we have x to the 1st power taken to the b power, which means we take that 1 times b, which is x to the b. And then we take this n to the a, and we're going to let that b hit the a, and we have n to the a times b. So our answer is x to the b, n to the ab. This works no matter how many things you have in that parentheses. So here we have m to the a power, n to the b, and p to the c, and we're going to take that all to the t power. So we are going to let that t hit a rainbow. We're going to send it into every single one of those terms and let it hit every base. So we multiply a times t, b times t, and c times t, and here's our answer. M to the at, n to the bt, p to the ct. Okay, so here we have some examples down here. We have to be careful because even when we have a coefficient like this 3, we have to apply that 3rd power to that 3 as well. So for this one, this would really end up being 3 to the 3rd power is how we would think of that, because that 3 really has a 1 there as an exponent, although we never write it like that. And then we have y squared to the 3rd power, which is going to be 2 times 3, which is y to the 6th. So then if we simplify that, that gives us 3 times 3 times 3, which would be 27, y to the 6th power. All right, I'd like for you to go ahead and try 2 and 3. If we could just pause the video, try those, and then we'll go over the answers. All right, so you should have worked those problems out. What we have with number 2 is we are going to take, this is like 6 squared, because we're going to apply that 2 to that 6, so 6 squared, and then that's going to be x to the second power and y to the second power. And if it helps you to think of this x having a 1 as an exponent and the y having a 1 as an exponent, and just multiplying that 1 times 2, that's what we get there. So then we simplify, we've got 36x squared y squared. On number 3, we have 3 cubed, so I'll go ahead and write it out, 3 cubed, and then x to the 2 times 3, which is 6, and y to the 2 times 3, which is 6. And now we want to go ahead and just do this, 3 to the third power, so that's 27, x to the 6th, y to the 6th. You don't have to write this step like this, but I like to write as many steps as possible. All right, now we're going to continue this power of a power property, and we're going to look at situations where we actually have fractions in our parentheses. So we call this power of a quotient property because we're dividing here, n divided by x. So again, we're going to think of our rainbow, and we're going to send the power into the parentheses, and we're going to let it hit every base in the numerator and the denominator, and that's the only difference between power of a quotient and what we did up here with power of a product, is we're going to apply the exact same process, but we need to also do it to the denominator. So here in this example, we have m to the a, n to the b, over p to the c, and we're going to take all of that to the t power. So that means I want to apply that t to every single term. So I have m to the at, I multiply the a times t, n to the bt, take b times t, and p to the ct, which I have there. Okay, so some examples here. We have b squared. So we're going to take that b, I'm going to write this a little bit bigger because I have room here. So b to the second power, and then we are also going to apply that to the c, so that's over c squared. Okay, we're going to look at this one right here. So here we're taking 3b over c and we're squaring it. So just like we did with the powers up here, we're just going to take that 3 and we're going to square that. And we have this b, which is essentially b to the first power, so we take that 1 times 2. And then we can't forget the denominator, so we have c squared. And then when I go ahead and simplify, I end up with 9b squared over c squared as our answer. Okay, go ahead and do number 3 on your own, and then we'll check it together. Okay, so your answer should have been 9b to the 4th over c to the 6th power. The last rule that we're going to look at is dealing with negative exponents. So remember when we had reciprocals or inverses, where we just take something and we essentially flip it? That's what we're going to do with these negative exponents. To make the negative exponents positive, and a negative exponent would be that -2 here, we need to kick it downstairs, the opposite of where it currently is. So I could rewrite n to the -2 power as n to the -2 over 1, right? Anything that is just in the numerator I can write as a fraction, as that whatever that term is over 1. And the reason why we're going to do that is because to get rid of that negative, we want to kick it downstairs, which means we want to just flip these. So I end up with my 1 in the numerator, and when I do flip it, that n to the -2 becomes n squared. It's positive. The same thing happens when we have 1 over n to the -3, except this time, to make that negative exponent positive, we're going to kick it upstairs. So we're going to flip the fraction where we have the 1 in the denominator, and this n to the -3 goes to the numerator and becomes n to the 3rd power, which then we can just simplify as n to the 3rd. Okay? Remember, if the exponent is positive, don't kick it around, don't do anything with it. Just leave it. We want it to be positive. So some practice examples. Here I have b to the -8 power. So if I rewrite this as b to the -8 over 1, I can kind of see it now as a fraction. So in order to get rid of that negative, I'm simply going to flip it, and I have 1 over b to the 8th power. Here I have my negative exponent in the denominator. So in order to get that negative exponent into a positive, I'm going to flip it. So that gives me z to the 3rd power, which would be over 1. And then I'm just going to write that as z to the third power. And I like to put little lines through my z's so it doesn't look like a 2. Okay, for number 3 here, now we want to pay attention. I have x squared, so we want to leave that. We don't want to kick that one around, but I do have that y to the negative 4th power in the denominator. So in order to get that y to the negative 4th power, I could write this as x squared times 1 over y to the negative 4th. And when I do that, then I'm going to kick that upstairs so that it becomes positive. So that's x squared times y to the 4th, and that's my answer. Okay, go ahead and do number 4 and number 5. If we could pause the video and then see how you did. Okay, so here we should have gotten c to the 4th over b to the 3rd. Here we want to leave that c to the 5th in the denominator, and so we want to leave that where it's at. And that means, though, that we do need to take care of this b to the negative 5th power. So that b to the negative 5th power becomes 1 over b to the 5th power so that it's positive. So we have a positive exponent, and we're going to leave that c to the 5th in the denominator. So that's our answer there. And those are a little bit tricky. All right, so now what we have are some practice problems where we're going to get rid of the negative exponents first, because we always want to do that, and then we want to apply the other rules that we have. So here, b to the negative 3rd power, we're going to put that in the denominator, and we're going to put the b to the negative 8th power, we're going to kick that upstairs, so we're going to end up having b to the 8th over b to the 3rd power. But now we know, because of the quotient rule that you learned last block, that we can simplify this. So our quotient rule says we are just going to subtract our exponents. So this gives us b to the 5th power. And for this example here, we have z to the 6th over z to the 4th. We're kicking this one upstairs and that one downstairs so that they're positive. And then we have 6 minus 4 for our quotient property, which is z squared. For this one, we have x squared. And we're going to leave that where it's at. We want to put the x to the negative 4th in the numerator. So that's going to be x to the 4th. We're kicking it upstairs so it's positive. But now we remember also from our last block that we know our quotient, or not our quotient, our product property. And when we are multiplying these two terms, we are going to add the exponents. So we got x to the 6th power. So you see how even after you understand each of the rules, we have to be very careful to make sure we know which one to use in what situation, and really just keep them straight in our minds. All right, so to finish up our notes, you should have gone through and worked out all these problems, and we just want to check them quickly. So this is x to the 6th power. Here we have b to the 8th power. This ends up being 1 over b to the 10th power. This is a to the 4th, b to the 2nd. Careful on this one, you just end up putting, whatever was in the denominator in the numerator, whatever is in the numerator, kick it downstairs, and then we're going to subtract, so we get a to the 4th, b to the 2nd. Here for evaluating expressions, we have 1 over 2 to the 3rd power, and sometimes we don't think about just taking our coefficients or just regular numbers and taking them to a power that is negative, but we can do that too. So 1 over 2 to the 3rd, we kicked it downstairs, becomes 1 over 8. Here, I've switched them both, so 2 to the negative 5th went in the numerator, I kicked that upstairs, that went downstairs, and then I can use my quotient rule. 5 minus 4 gives me 1, so that's 2 to the 1st power, so it equals 2. And then here I have 1 over 4 to the 3rd power, kicked it downstairs to make it positive, and that simplifies to 1 over 64. All right, so that takes care of all your rules. So at this point today, what you're going to be doing is practicing everything that you've learned from last block and the new ones from this block as well. So on the back side, we have a lot of great practice problems, and what I would like for you to do is work through these problems and then go ahead and check them with a neighbor so that you make sure that you're getting them right. And we also have another 18 problems here on the other side. So your goal here is to work through all of the problems and check them with a neighbor so that you know that you are on the right track. And then we also have more practice problems that you can work on and homework as well. All right, that's it for now.